In this video, we are going to solve two problems involving Fourier series. The first problem is we're going to find the Fourier series for the function f of x equal 1 when x is between negative pi and 0, and negative 1 when x is between 0 and pi. And the second problem is to find the function to which the Fourier series for f of x above converges. So let's start with part A. So I wrote all the formulas that we need. The Fourier series has this expansion, and then a naught, a sub n, and b sub n are given by the formulas. Now, taking a look at the function that we have, we can conclude that L is equal to pi. So then let's calculate a sub 0 is going to be 1 over pi integral from negative pi to pi of f of x dx, and our f of x can be split into integral from negative pi to 0, which is between negative pi to 0, it's 1. It's going to be of 1 dx plus integral from 0 to pi of negative 1 dx, as that is the expression for 0 to pi. So then we can calculate these integrals really quickly. 1 over pi times x from negative pi to 0 minus x from 0 to pi. So 1 over pi times 0 minus negative pi minus pi minus 0, which gives us 1 over pi times pi minus pi, so it's actually 0. A naught is equal to 0. Let's calculate a sub n. A sub n is 1 over pi integral from negative pi to pi of f of x. It has two expressions, so I'm just going to copy it from now like that. Cosine of nx, because we have n pi x over L, and since L is pi, the pi can cancel. So this is going to be 1 over pi, and let's separate from negative pi to 0 of 1 times cosine of nx dx, and then plus integral from 0 to pi, and then it's negative 1, right? We have 1 and negative 1, and then negative cosine of nx dx. So let's, you can pause this video, calculate your own integrals, and then check if we have the same answer. I got 0 by doing the computations that I've done here. And keep in mind, when you have sine of negative x, that is it's equal with negative sine of x, because sine is an odd function. Also, I used the result that sine of 0 equals 0. So we found a sub n. Let's do b sub n. So b sub n is given by this formula, 1 over pi integral from negative pi to pi of f of x sine of n pi x over L, but since L is equal to pi, this cancelled, and so we have 1 over pi, and then we separate it into integral from negative pi to 0, and f of x it's 1 there, so it's going to be just sine of nx dx, and then plus integral from 0 to pi of negative 1 sine of nx dx. Again, pause the video, do the problem, and then check if we got the same thing. And so we get this answer, and here I use the fact that cosine of negative x is equal to cosine of x, because cosine is an even function. Just look at the graph of cosine function. You're going to see that it's symmetric with respect to y-axis. And I'm also going to continue by calculating what's cosine of n pi. So I want you to think of all these possibilities. If n equals 0, 1, 2, 3, and so on, what do we get? Well, if n is even, like 0, 2, 4, and so on, we get 1. If n is odd, like pi, 3 pi, we get negative 1. So that means cosine of n pi, it's equal to negative 1 to the n, because when n equals 1, 2, 3, and so on, this expression here, which is very important and useful, this one helps us calculate the n pi. So basically this is equal to negative 2 over n pi times 1 minus negative 1 to the n. So we calculated all the constants. We saw that a sub 0 is 0, a sub n is 0, b sub n gave us a value. So what does that mean? It means the Fourier series is going to be equal to sum, as n goes from 1 to infinity, of b sub n, which is given by this expression. So is negative 2 over n pi times 1 minus negative 1 to the n, and then times sine of nx. So this is the Fourier series of the function that we started with. So very interesting, right? When we started with a function that was just 1 and negative 1 on some intervals, and we were able to write it in terms of the sine function. Now let's take a look at the part B. So in part B, they were asking us to find to what function the Fourier series converges. So again, f of x was given to be 1 for x between negative pi and 0, and negative 1 for x between 0 and pi. So I want to find out, let me call it f tilde, the function to which the Fourier series is going to converge. So in order for us to find that, I'm going to draw f of x in a coordinate plane. So we're going to get x or y. So we get negative pi, 0, pi. So the graph between negative pi and 0, it's 1. So let's put here 1, and I'm going to put open dots because it's not defined at those values, at the negative pi and 0, and then negative 1 here. So the function, this function is continuous in between the values, but we don't know what happens at the endpoint. So I'm going to do this. I don't know exactly at what it actually converges at negative pi. I know that between 0 and negative pi is going to converge to 1. I don't know what happens at 0. We are going to discuss that. I know that between 0 and pi is going to converge to negative 1 because it's continuous there. And I need to find out what happens at pi. So let's start the discussion. Now, the Fourier series converges at the function when the function is continuous. But when the function is not continuous, at the points where it has discontinuities, like just let's take a look at 0, right? At 0, there is discontinuity. Here, to the left at 0, right, as we approach 0, we are getting the limit, it's 1. As we approach 0 from the right, we get negative 1. Well, when we have this kind of discontinuity, the Fourier series is going to converge to the average between the left limit and the right limit. So at 0 is going to be 1 plus negative 1 over 2, which is actually going to be 0. So for this point, we could find out from the graph. Now, looking at the graph and trying to find out what happens at negative pi, right, at this point here, it's negative pi. I don't know, so I know what happens when x is approaching negative pi from the right, but I don't know what happens from the left. So because of that, we are going to create an extension of the function. So I'm going to go negative 2 pi and negative 3 pi. So the extension is going to look like this. Still 1 between this, and then negative 1 in between these two. And so I'm going to make an extension on the other side too. 2 pi and 3 pi. So the graph is going to be 1 in between these two and -1 in between these two. So now, trying to figure out what happens at -pi, right? What I'm going to do is I'm going to see what happens to the when x is approaching -pi from the right. Well, from the right we get 1. From the left we get -1. If we average this, we get 0. And let's take a look at pi as well. If we approach pi from the left, we get -1, plus when we approach pi from the right, we get 1. Average that, we get 0. So basically, the function to which the Fourier series, well, I said sine series, but it's correct because we got just a sine series converges, is going to be 0 for x is equal to -pi, 1 for x between 0 and -pi, 0 for x equals 0, -1 for x between 0 and pi, and 0 for x equals pi. I hope this helps.